name is Abhijit Rai. I graduated from Columbia Business School in 2014, and I am a VP in financial services firm, and I do this because teaching is my passion. What are the expectations from today? So this today is basically about you. The most you can get out of today is by asking questions, making sure you understand the approaches. Start with a simple question. This is question number 436 in official guide to GMAT, and this is also a DS07953. So if you don't have official guide to GMAT 22, that is absolutely fine. You can find this question 07953 in any version of official guide. This has been going on in official guide for some time. Very standard word problem for GMAT. Okay, so let's look at pure logic, right? And then we will try to look at math here. Kim and Sue bought total number of roses and daisies, right? So we have two flowers, roses and daisies. And what is given to us is for both Sue and Kim, the number of roses and daisies is same, right? So let me just mark K as Kim and S as Sue. And this is the number of roses and daisies, and this is the number of roses and daisies here for Sue. Now let's assume at this point that they had exact same number of flowers, and not just that, they had exact same number of roses and exact same number of daisies. So that is why this R and this R is same, and this D and this D is same. That is our starting point for this particular reasoning. Now the other information that is given to us is that roses are $1 and daisies are $0.5, and we are going to start using this information in a little bit, right? The question for us is, when somebody has purchased these roses and daisies, whose purchase price, total purchase price is higher, Kim's or Sue's? When we are starting with the same number of roses and same number of daisies, we know that for both of them, the purchase price would be same. Now let's keep this as same for Sue, and let's start thinking about Kim. Let's assume that Kim increases the number of roses. So if she gets one additional rose, she would have to get one less daisy, right? Because the total number of roses and daisies are same for Kim and Sue. So this means that when I do +1 here and -1, what happens to my price? My price, the new price, would be, so I'm going to call this PK. New price would be roses is $1, so it will increase by $1. Right? And it will also reduce by -0.5 because I haven't bought a daisy. So it will reduce by 0.5. So new price would be P plus 0.5, right? So P is my initial price. So as long as the number of roses for Kim is greater than number of roses for Sue, the price for Kim is going to be more than the price for Sue. Now if you keep increasing this, +1, +2, +3, this will keep on increasing. As a result, this will keep on increasing because the effect of increase in price is less than the effect of decrease in price of daisies, right? Let's say we did it a different way, right? We said, okay, let's say Kim reduced the rose and increased the daisy. So what I'm saying is, she bought one rose less and one daisy more. The price would have looked like P minus $1 for the reduction of one rose plus $0.55. That equals P minus $0.5. Again, as you can see, if the number of roses for Kim is less than number of roses for Sue, then the price is going to reduce. So we already have an understanding of when the price for Kim is going to be more than price for Sue, and that is when the number of roses for Kim is greater than number of roses for Sue. As long as we know that the price of Kim would be greater than price for Sue. If the number of roses for Kim is less than number of roses for Sue, it will be the reverse. And if they are equal, then everything will be equal. And if you imagine, all of this is driven by this constraint that the total number of flowers that they have bought is same. So it doesn't matter whether they have bought more roses or daisies, total number of flowers is same, and let's say that is 10, right? So in statement 1, we are given that Kim bought twice as many daisies as roses. What does that mean? So this is only for Kim, right? So Kim is given to be R plus 2R. This is what Kim's number of flowers is, and the price would be dollar multiplied by 0.5. But here's the thing, we don't know anything and we need a comparison between Kim and Sue. We don't have any way to compare between Kim and Sue in this point, right? We only know Kim's, and Sue's number of flowers could be exactly same. Hence, this is clearly insufficient to answer the question. In statement B, we are given that Kim actually bought 4 more roses than Sue. So this is this particular scenario that we had talked about, where Kim is not 1 roses more but 4 roses more, and we know that even with 1 rose more, the purchase price for Kim is more than Sue. So if there were 4 additional roses, then Kim would have paid additional price for it. So this is sufficient to answer the question. Hence, the answer to this question is B. Only statement 2 is sufficient. I'll take a moment to take any questions on this approach, and then I will talk about the mathematical approach to solve. And then in the takeaways, we will talk about which approach is better and what to do in the exam and how to prepare for it in the exam. Any questions? Okay, doesn't look like there are questions, so I will just continue. In terms of math, now math is again about setup, right? So we are going to do the same thing. We are going to say this is Kim and this is Sue, and let's say the number of roses that Kim bought is RK and the daisies is DK, and RS and DS. Okay, so the total number of roses we know is, total number of flowers we know is same, so this will be equal. The price for each of them would be PK would be equal to RK plus 0.5 DK, because RK is $1, and for PS would be RS plus 0.5 DS. Okay, so first we are going to use this particular equation, because these are equal, to come to a conclusion. So let's do this. RK plus DK equals RS plus DS, and that implies RK minus RS equals DS minus DK, which is also equal to minus DK minus DS. And I will come to why I included this minus sign, but this is just my way of representing everything with Kim first and Sue second. Kim first and Sue second. All right. Then we have to figure out if the purchase price of Kim is greater than purchase price of S. So RK plus 0.5 DK is greater than RS plus 0.5 DS. This is the other question, right? So this is our question. Is this true? Because this is the purchase price of PK and this is the purchase price of Sue. So this boils down to RK minus RS, taking this RS on the left hand side and taking the DK on the right hand side, is greater than 0.5 DK minus DK. Right, and then I will take all of this on the right side, on the left hand side, so that becomes RK minus RS minus 0.5 DS minus DK greater than 0. And this turns out to be, if you resubstitute this DK minus DS is DS minus DK is same as RK minus RS, you would get 0.5 RK minus RS greater than 0, which will be same as RK minus RS greater than 0, which means So, and statement 2 provides the information that Kim bought more roses than Sue. The question boils down to, is RK is greater than RS, which is the roses for Kim greater than roses for Sue, and hence statement 2 is sufficient to answer the question. I'm going to take a pause here to see if there are any questions around this, and then we will go to the takeaways. In the takeaways, we'll talk about which approach is better and how to think about these word problem approaches. Okay, so sounds like there are no questions out there. So let's get started. So the reasoning way, right? The logic way or the reasoning way is always about setup. When you are trying to do any kind of word problems, it is about setting up. If you recall, I started by setting up roses plus daisies and roses plus daisies as same, and then started to reason by buying additional rows for K and one less daisy for Kim. Now, how did this approach occur to me? That's the question you should be asking at this point. Why did you start here? And the answer to that is, the more you practice, the more you are aware, right? I started here because this was a constraint I was given, and when you're trying to solve a logical problem or a problem in a logical way, you start with the constraints you are given, and the constraint that I was given was the number of flowers is same. So I started here, right? And if you remember, I started the exact same place when I was solving the math way, which is equating RK plus DK and RS plus DS, right? The second reason I started with them having the same number of roses and same number of daisies was so that I can actually figure out what happens when a little bit of roses increases or a little bit of daisies decreases and things like that, so I can figure out a trend. Now, all of this is not going to come very simply to you, only with practice, right? But the important thing about the reasoning is setup. The more you practice, the more you will start understanding the setup right, and you will be able to set it up. It comes with practice. However, the approach is think about the constraints and try to start there. Those could be your starting points. They are not always, but they could be a starting point. The good part about the math way is that it is generic. It is applicable to all. In the math way, all I use is equations, all I follow is the pattern, and I get an answer. RK is greater than RS, right? We saw that. So we rephrase the question into RK greater than RS only in mathematical terms. Again, it needs a little bit of practice, but here you know where to start. It is easier to set up in equations and inequalities than the reasoning way. And which method to practice, right? So this is two-step answer. Which method to use in the exam? It totally depends on you, whichever you are more comfortable with, or whichever method you feel applies to you better during the exam. And you don't have to get to one method and say, okay, I am only going to use logical method in my GMAT exam. You can absolutely mix and match. Even in the same problem, you can go and follow logic to a certain point and then use math. And the next question one of the next questions we do would actually include that, where we one of the methods is we will go follow the logic to a certain point and then suddenly you use math to get the answer. But when you are practicing, practice both ways, right? If you don't find a solution which has both the logic way of solving it and the math way of solving it, find somebody who can give you that answer. Ask in the forums, ask in the WhatsApp group if you're part of my WhatsApp group, or Facebook group. But find out both ways, and just don't look at the solution. Actually look at the solution, understand, and ask the question. If you're looking at the logical way or the reasoning way, why did they start there? The more you start questioning that, and that starts becoming a point of reference for you, this is where I start, this is why they start. Because once you start somewhere, then you know how to proceed, but the starting point is the most difficult point there. All right, if there are no further questions, I am going to start with the question number 2 at this point. Okay, so this question is kind of hard for GMAT, right? 40% of people are getting this question wrong. And once I solve this question, you would understand that it is not really the hardness of the question that is important, but the fact that it is a maximum minimum question, and applying logic to it is more difficult, and applying math math is also very difficult because it's maximum and minimum math. If you're not, and I have a video on maximizing and minimizing strategies on my channel. I will give you the link later for that. So let's get into the question really quick. Right, so we have 64 classes and 37 teachers, and we are given some constraints, and these constraints are important, right? So each class has one teacher, so it can't be that one class has two teachers, and each teacher teaches at least one class, so you can't have one teacher with 0 classes either. But there are more classes than there are teachers, so that means that some of the teachers would get more than one class, right? And what is also given is, if there are teachers who teach 3 classes, then you want to denote that number of teachers as n, and the question is simply asking you minimum and maximum values of n. Now, it's simply asking you the minimum and maximum values of n, doesn't mean that it is easy to derive those values of n. So I'll take a pause here and ask whether you want the logical reasoning approach first or mathematical approach first before I get into the question itself. For math, so we will start with mathematical approach, and then of course we are going to talk about 3 approaches here. So first approach will be pure math. The other approach would be logic, and then we'll talk about a mix and match approach. Again, the point being, it is okay to use any of the approaches that are good for you. You don't have to kind of stick to just one approach and live by it. So let's talk about pure math approach, right? So we are given 64 classes and we are given 37 teachers, and we are also given that there are teachers who teach 3 classes and they are denoted by the letter n, right? So let's do this. Let's divide these teachers into teachers who teach 1 class, teacher who teach 2 classes, and teacher who teach 3 classes. We are already given the number of teacher who teach 3 classes is n. The number of teacher who teach 2 classes, let's call it y, or y. And number of teachers who teach 1 class, let's call it x. Okay, so the total number of teachers given to us is 37, which means x plus y plus n is 37. The total number of teachers is 37. The total number of classes given to us is 64. So since n teacher teach 3 class each, this will be 3n classes. These guys teach 2 class each, so this will be 2y classes. And these guys teach 1 class each, so this will be x number of classes. And this is the equation number 2, right? Now we have 3 equations and 2 equations and 3 variables. However, if you can quickly notice that this has the same magnitude, x and x. If you subtract these equations, the x would cancel out. So I will call this equation number 2 and I will call this equation number 1, and I'm going to do 2 minus 1. So x minus x cancels off. 2y minus y is y plus 2n equal to 27. Right? So number of people who are teaching 2 classes plus 2 times the number of teachers who are teaching the 3 classes equals 27. Now the question basically asks me n minimum and n maximum. Now I'm going to apply some of the uh, some of the properties that I had discussed in my minimizing and maximizing strategy video without going too much into the basics. So in the end, we need to find this number, right? Minimum and maximum value of this. So let me just first express everything in terms of this number. So n will be 227 minus y divided by 2, correct? I just simplified this equation into this. Now n minimum would be 27 minus y maximum, because I am subtracting y from something. The more the y is, the lesser the resultant would be. Let's not forget divided by 2. And n maximum would be 27 minus y minimum by 2. Now, here is where a lot of people get stuck, right? This is about, again, setting up the question the right way. We have set it up. We have come to a conclusion. Now, what do? We don't know anything about y minimum or y maximum. Well, we do, right? Because the number of people who take 2 classes, which is represented by y, the minimum value is literally 0. Let's take nobody takes 2 classes. Everybody takes either 1 class or 3 class. So let's say y minimum is 0. What do we get? We get n maximum as 27 by 2 equals 13.5 classes. This is not possible. So 0 value of y minimum is definitely not possible. So I am close to the answer, and actually if I'm practiced enough, I can get the answer right here and there. But since we are actually not that practiced yet, we are going to say not a possible case. I'm going to change my y minimum to 1 and go from there. Right? When I take y minimum as 1, I get n maximum equals 27 minus 1 is 26 by 2. That is 13. And I can stop here because my maximum value is 13. I got the answer. And not just n maximum, I also got the answer of y minimum. If the question had asked me what is the minimum value of people, of the teachers who are teaching 2 classes, right? So you could just stop here, but because we want to be comprehensive, let's look at getting the minimum value of n. All right, so now the minimum value of n, the question is, why can't it be 0? Why can't y max be not 27? The number of teachers is 37, right? So the 37 teachers have taught 1 class each. Then another level of teachers could be teaching 27 classes. The rest of the 27 classes, all the teachers could teach, which means the number of teachers that actually teach 3 classes could be 0. So logically, if you think about it, and mathematically, I can take 27 because 27 is less than the 37 teachers that are available. I can easily take 27. So my y max is 27, which gives me my n minimum as 0. So the minimum value is also verified, and hence the answer is A. Now I could have done very similarly, and I will leave this as an exercise. I could have done this very similarly the other way around. I could have expressed y in terms of like this and found y max and y minimum, and I could have solved for number of teachers who have taught 2 classes, the minimum value and maximum value, and that would be absolutely right. So this was the mathematical approach. And once you follow the approach, and actually if you don't have the basics for it, if you look at my mathematical minimizing and maximizing strategies video, you will get the basics also. You will realize that solving these kind of problems is not difficult if you start doing them and taking a little bit of practice. I will take a pause here, see if there are any questions on this approach. If not, then I will move to the next method, which is completely logic. We are not going to use math. Although math and logic are very similar, but we are not going to use a lot of math or equations here. All right, so we'll start with this logical reasoning, and think about this logical reasoning as, again, let's set up the question quickly. Again, logical reasoning is all about setup, right? So I have 64 classes and I have 37 teachers, and some of my constraint as each class had one teacher and each teacher has at least one class. So let me just write down 64 classes, but I'm not gonna draw 64 circles. I'm going to do something like this, right? So this is my class number 1, class number 2, class number 3. This is my class number 36, class number 37, class number 38, and this is my class number 63 and class number 64. Okay, now I have been given that there are 37 teachers. So, and I'm clearly given that each of the teachers get at least one class. So let me just say that the first 37 classes right here are taken by my teachers. So each teacher now has one class. The first 37 classes. How many remaining classes are left? 27, which is just 64 minus 37, right? Any new class I start filling, then the teacher would be teaching 2 classes at that point. It doesn't matter which teacher it is, he will be teaching 2 classes at this point, right? However, I am worried about the number of teachers that teach 3 classes, and maximum and minimum of it. So let's start with how to find the minimum. To find the minimum number of n, which is the number of teachers that teach 3 classes, let's just maximize the number of teachers who are teaching 2 classes only. So they won't get to 3rd class. So if we maximize the number of teachers that teach 2 classes, the number of teachers who get 3 classes would be the minimum, right? So let me start giving one class each to the let me start giving from the remaining classes one class each to the teachers. So let's say this I give to T1, this I give to T2, and all the way here T26 and T27. Mark that I had 37 teachers. So if I start giving one additional class to each teacher from T1 to T27, by the time I reach T27, I have given up all the classes. So there is no teacher who gets who gets 3 classes at this point, right? So n minimum value is 0. Now that brings our answer choices to these 2 things. Right? It doesn't help us, it doesn't get to the answer, but we know that C, D and E cannot be the answer because n minimum is 0, because we have given the rest of the classes to one teacher each and we ran out of the classes and we had more teachers. So one teacher can teach 2 classes in this scenario. Now again the scenario remains same. Now let's start giving 2 classes each to the teachers till we are remaining with 1 class, for example, or any none class, right? So that way we are maximizing the number of teachers who are getting 3 classes. So what does that mean? I have already given 3 classes. I have already given out these 37 classes because each teacher has to get 1 class. Now from 38 onwards, I am giving T1 and T1. And then T2 and T2 pairs like these for the rest of the 27 classes, right? Hopefully that is clear. I'm basically saying T1 already had the C1 class and now I'm giving 2 additional classes to him. So I am maximizing the teachers who are getting 3 classes. So T1 now has 1, 2 and 3 class. T2 was already having the class C2. Now I'm giving T2 2 additional classes. So now T2, teacher 2 also has 3 classes. and so on, you would see that since these are pairs and there are 27 classes left, you would have T13 and T13, another pair, and then T14 would be individual. You will not have any additional class. So you have 13 players like this, which means 13 teachers who would get 3 classes and 1 teacher which would get only 2 classes at the end. So you are maximizing 3 and you are saying 13 teacher are the maximum number of teachers who are getting 3 classes, and in this case the number of teachers who get 2 classes is not 0, it will be just 1. I'll take a pause here and see if there are any questions, and then we'll go into a mix and match approach on solving this question. Okay, so the mix and match approach looks very similar to the logical, at least the start of it looks very similar to the logical approach we just did. We again think about the 64 classes and we think about the first 37 classes that we have already given to the teachers. So each teacher has gotten 1 class. That was one of my constraints, right? And we are left with 27 classes that we need to distribute. Let's assume all of the 27 classes are given to teachers who teach more classes than 1. So 1 was already given. Now the teachers can get at maximum 2, because one of the constraint is no teacher teaches more than 3 classes. So we can give 2 additional classes to each of the teacher. So I can just do 27 divided by 2 equal to 13.5. So I know that nobody can get 0.5, but I could still manage to get 13 classes given out to other teachers, and that 1 class will be remaining. So my maximum value would be 13. The problem becomes very simple if you kind of combine logic and math very, very quickly. And the answer comes out to be 13. Now, if any other answer choice had another 13 in it, then you would have gone further in your reasoning to figure out how to get the minimum value. But since here the maximum value is already 13, the problem is solved for you, right? So 3 approaches. Which of this approach is better? Let's talk about that. The important thing for you to know is that word problems can be solved with either math or logic, and it is absolutely okay to even mix and match the approaches, right? Pure math approach again is very, very applicable, and if you practice enough, you know how to set up the equations. It is very generic. It can apply to any word problem. However, that does not mean it is always better, because you can get to the answer faster with a logical approach as well. The problem with the logical approach though is that if you don't know and you haven't if you haven't practiced setting up the problem properly, then you will run into issues, right? So the most important thing is it is okay to use both the approaches, but you have to practice, right? When you see a word problem like this, always practice. Practice not just with math approach. Don't just look at a solution and be contented that, oh, I have found the solution for this problem and move on. Ask for a logical approach versus a mathematical approach and solve it both ways. But most importantly, ask this question: how did you set up? How did you set up, or how did you start in a logical approach? Let me just go back a second to talk about where did I start in the logical approach. And if you remember in the previous question, I said I started with a constraint. I did the exact same thing. I started with a constraint, and my constraint was 64 classes given to 37 teachers, one teacher at least have to have one class, and each class only has one teacher. So I started drawing out 64 classes and giving out 37 classes already, because that is given to me. The problem is on the rest of the classes, not in the first 37 of the classes. And this is how I set up the problem, right? It could have been set up differently by somebody else. However, they will also start from the constraints that are given to us. So if you can identify the constraints in the problem clearly, write them down, especially when you are practicing, start your logical setup or reasoning setup from the constraints that are given to you. All right, I'll take a pause here, see if there are any questions. If not, I'm going to go to this one. This is a geometry problem with 3 hidden traps, and almost 50% people get this question wrong. When I solve this question, I will mark where people get this question particularly wrong. And we have 15 additional minutes. Oh, there was one question. The question is 600 or 700 level. Let me just double check that. Probably around 650 plus level question, that one, or maybe 700, somewhere around that range. Medium to hard difficulty, but definitely not a 750 level question, the teacher's one. This question, however, is the geometry question we are going to do next is a 720 plus level question. However, when we solve it, you will realize that it shouldn't be. However, but when you are in the exam and you are running against time, it becomes difficult. All right. Any other questions? Okay, let's get this started. So in this question, this is exactly question. This is a very small question, one of the hardest questions in official guide to GMAT. This is question number 464 in OG 22, but you can also find it as 02888 DS in other official guide to GMAT, or you will search for it online. All right, the question is, what is the value of K? K is, and this is the diagram that is given to you. And it's a data sufficiency question, so you have to actually find, you don't really have to find the value of K, but make sure that the value of K is unique. If the value of K is not unique, then you cannot get the answer. Sometimes you can determine if the value of K is unique very quickly, other times it is difficult. All right, so if there are no additional questions, I will like to get started. This is probably the last question we will be able to fit in today's session. So let's get started very quickly on it. We are given these two sides are parallel, and this angle right here means that it is a 90-degree angle. So we are looking at kind of a square, right? Because all of these are 90-degree angles. Let me extend these lines here to make the square complete. So this line here would be 15. This line here would be 15, right? Because all of these angles are given to be 90 degree. All right. We are given two options here, statement A and statement B. I will start with statement B, and we will go to statement 1 later. And because statement 1 is a little bit more complex and I want to spend good amount of time there. So perimeter of this shape is given to be 60 feet. So for calculating the perimeter, you have to basically find the sum of all sides. That's a perimeter of a polygon, right? So 15 plus K plus this side plus this side plus K plus 15. That's going to be the perimeter. So let me just quickly mark what these sides would be. So this is 15, right? So, and we are given that this side is K. So this would be 15 minus K, and this would be 15 minus K, right? So my equation becomes 15 plus K plus 15 minus K plus 15 minus K plus K plus 15. That is the perimeter. So let me just write it down. 15 plus K plus 15 minus K plus 15 minus K plus K plus 15 equal to 60. We have one equation and one variable. So we can easily find the value of k, so it should be sufficient. Am I right? And this is where the first GMAT trick is. If you assume that, you will get into problem and you will get this question wrong. The trick here is, if you cannot say this is a one equation and one variable till you simplify the equation. Just because you have only k here, you are assuming that this is the equation, but it's not. Actually, if you see here, k and k cancel off. This k and this k actually cancels off, and you have only 60 equals 60. There is no way you can actually find the value of k. So it was a trap. And the trap was this thinking that if I see one equation and one variable, I will be able to solve for that variable. So if you stop there and mark the answer as sufficient, you would have gotten it wrong. And that is one of the reasons why this problem is very difficult. Not because the problem itself is difficult, because it has these kind of traps and it plays on your usual behavior and usual way of thinking, which is one variable and one reasoning. We also know that statement B at this point is not sufficient to answer the question because of this very reason. All right. So very interesting problem. You already saw the first common mistake people make. And this is a very common mistake. Before even going into statement 1, where we are going to see another 2 common mistakes people make. So let me just quickly draw this out again to find the area and see if we can get the value of k. So we are given this is 15, this is k. We saw that we talked about this being a square, so this is also 15. So this side is 15 minus k, and this side also is going to be 15 minus k, which means the area of this and this side, of course, would be 15 minus k is also. The area of this little square is 15 minus k whole squared, and the area of the big square is 15 squared, and the area of the shaded region is just the big square minus the small square, right? So far so good. Everything is in terms of k. We are given the area is 189, so I'm going to just write this thing down very quickly. Equals 189. I can solve it with a square minus b square equal to a minus b into a plus b property. So this would be 15 minus 15 plus k into 15 plus 15 minus k equals 189. And I have it written down here so that we don't spend too much time on quadratic. My assumption is quadratic is already practiced by you all. You will get this equation k square minus 30k plus 159 equals 0. 189 equals 0, right? And here is the thing. What did we say? What is the value of k when we started, right? When we said that in a data sufficiency question, k has to be unique. In this question, however, we are given that k has a quadratic equation, right, that it satisfies. So that means k has possibly 2 different values. So statement A is insufficient. And if you think that, that is trap number 2 that you are going to fall under. Another big trap, right? And here is the reason. When you actually solve for k, you might get one value as positive and one value as negative, and of course side of the squares cannot be negative, or you could get one value which is completely impossible based on the constraints that is given. However, a lot of people make that another mistake where they assume k has 2 values, and since k has 2 values, it's not unique, and they mark this statement as insufficient also and get the question wrong. All right, so don't make that mistake. Yes, we have to figure out if k is unique, but we have truly figure out if k is unique. Without solving this equation, you will not know. I'm not going to go into detail of solving the equation because that is just going to take time, and I am assuming you already know how to solve for quadratic. You will actually get k equal to 9 and k equal to 21. And now you are going to say, well, look, Abhijit, there is no negative value. K has two possible values, both look fine to me. So again, k is not unique, which means it is insufficient, and I am going to move on. And this is the third mistake people make. So even if you get to this level and say that, oh, there are two values possible for k, I am going to move on because I don't get a unique value of k. That is the third trap and the third mistake people make. So even after doing the hard work and not falling for the first two traps, you get to this trap. And why is this a trap? Look at this value 21. Can k be greater than 21 when the biggest side on the square is 15? It's not possible, because then 15 minus k would be negative, and 15 minus k is the side of the square, right? So this 21 value is not even possible. So given the constraints that we have, the value 21 is not possible, and hence there is only a unique value of k given in the statement 1, and that is k equals 9. So statement 1 is sufficient. And this is why this question is difficult, not because it has very complicated math, but because it has traps and it plays on the general kind of rules of thumbs you have in your mind about one equation, one variable, or quadratic equation having two different values and things like that. And it uses that to kind of lull you into a trap. Now, getting this question wrong may not cost you a whole lot in GMAT, because this is substantially difficult question, but it depends on how GMAT is thinking about this question. GMAT may be thinking about this question as medium. We know that about 40-50% people get this wrong, so it is tough, but in terms of concepts involved, it is just a quadratic equation and actually solving for values. Not really that difficult in terms of quant involved here, right? So if the GMAT exam in their computer adaptiveness is thinking this is a medium problem, you might get this in the middle of the exam, and if you get it wrong, you might get penalized a lot more because you will drop a couple of question levels. I will take a pause here before we get into the takeaways, see if there are any questions. All right, so we have 3 more minutes left for the video for our session here. So let me just talk about some of the takeaways. The first mistake that we saw 3 mistakes, right? We started with statement number B. So the first mistake we saw was the mistake number 3 here, which is if we see one equation and one variable, just make sure you simplify the equation and you're sure that it is actually one equation, one variable, and the variables don't cancel out. Otherwise, you will fall into that trap. The quadratic trap was if you see two values or possibility of two values, don't just stop there. Make sure it is two values. And even when you get those two values, make sure that the one of those values cannot be discarded before marking it as not unique and insufficient. All right, I will hold tight for a moment to see if there are any generic questions or any questions about the question. I am looking for feedback as well. If this was helpful for you, please give me some feedback, and then we will close the session. I had more questions planned for it, but I hope you got a lot of values, and we have more questions planned for the next session. I'm going to take this session every week from next week, pretty much. Okay, looks like we don't have any more questions. So thank you everyone for joining. I wish you all the best for your exam. Looks like I might have a question. Thank you, Andrea. Glad you liked it. I plan to do this every week, so please join next week also. Again, I will announce it in the group so that you are aware of it. And any feedback on how to improve, what to improve, always welcome. I want to make sure that this is all the most valuable for you guys who are taking your GMAT in the near future. Thank you and have a great weekend.